Max Edmands, and I'm a staff product engineer here at Honeycomb. I'm excited to tell you about our newest beta launch, Honeycomb Metrics. Honeycomb has always been a state-of-the-art tool for observing what our services are doing in production. But sometimes it's important to go one level deeper and get some insight into what's happening inside the infrastructure that your applications rely on. Wouldn't it be great if we were also able to look at infrastructure metrics on this screen? Since you've already seen the title of this talk, it probably won't be a huge surprise to you that now you can do that. Today, we're unveiling a new collection of features for enterprise accounts that will give you and your team a window into what's happening in your infrastructure. Using this new Metrics Correlations tab, at a glance, we can see crucial contextual information that lets us understand how our infrastructure is doing and potentially diagnose or rule out issues that could be contributing to problems we're seeing in production. In this example, we're looking at a graph that is giving us a latency distribution of one of our production services. At the same time, we can see information about CPU utilization and memory usage of that service broken out by host. And since this service makes use of AWS Lambda, we also have a graph of what's going on with Lambda executions happening during this time span. So now that you've seen a preview of this new feature, I'd like to give you a quick overview of how to set this all up for your own application and how you can get the most out of it. For that, I'm going to show you how I've instrumented my own tiny demo application that I've named Polyhedron. My aim was to make this application super simple, but reminiscent of the kinds of applications that you might encounter in your day-to-day if you're working on production systems. Polyhedron is a simple dice roller app. I've written it in Golang. It's an HTTP server that will roll virtual dice for you. You tell it how many dice and what kind, and it'll roll the dice for you and respond with a total. So here in this example, I'll be sending a request to the app with curl, asking it to roll 2 6-sided dice in a row, and getting back 6 as the result. Rolling a few more times. I've already instrumented this app with OpenTelemetry traces. It's sending data to Honeycomb to this Polyhedron traces dataset. As you can see, the server looks pretty healthy with a spread of mostly quite low latencies. You'll notice that it's steadily receiving traffic. That's because I have a load generator process running over here in this terminal. If I head into this total requests graph and group by host name, you can see that requests are being handled by 2 different hosts running on 2 VMs that I have going on this computer. That's basically the sum total of how this app is architected. It's just an Nginx load balancer distributing requests across 2 servers, each running on different machines. And I can click into any point on this graph and see a trace corresponding with that time. Since this server is doing only one thing and it isn't networked, the traces only have a couple of spans. Back in the query builder, I'm really excited to show off this fancy new metrics tab. If I click it, it's hiding all sorts of useful stuff about what's going on with my infrastructure. Data about memory usage, CPU usage, process count, uptime, network utilization, and even language-specific stuff like the amount of concurrency in my Golang processes. They're all broken out by host, so if I'm hovering over a specific host's data in my main query, it'll highlight in the metrics queries. One neat thing about this metrics data is that it's all stored in the same columnar data store as everything else we receive. There are a couple of big benefits to this. First, you can run arbitrary queries against your metrics data in the same way you would any other data in Honeycomb. Here I've clicked on one of these metrics graphs, and you can see now that we're actually just on a different Honeycomb query results page with all the same features you'd get from any other query. For example, we already saw that we're grouping by host. But you'll also note that we're filtering to just established connections. What other states are there? So now we're seeing that across both of our hosts, most of the TCP sockets we're using are in the time wait state. That's interesting and could be potentially useful to know if we were running out of TCP sockets. Thankfully, we're not. We'll get a more interesting view of the data if we look at it in log scale. Now we can see a time series of all existent TCP connections for each host, grouped by wherever they happen to be in the TCP state machine. Let's filter to just a single host for a moment. Looking at the raw data tab for this host might give a clearer picture of what's happening under the hood. Now, we're able to see the stream of data that Honeycomb has received in order to render these time series. For any given minute, we've got 12 rows stored that track a measurement, the number of TCP connections for this host that have this state. If we filter down to just a single state again, say for example, established, we can see that we're looking at a very regular time series, with data points arriving more or less every minute. This is even more clear when we filter the query to just the last 10 minutes. We see 10 data points. This is probably the most fundamental difference between metrics data and what we were collecting back in our traces dataset. Here, we have a row stored for every HTTP request whenever it happens. This could be multiple times in a millisecond, could have a few milliseconds skipped. It's showing you a one-for-one picture of what users hitting your website are doing, and each row is super wide, giving you as much information as we can about the context of that request. This model makes tons of sense for data that's event-driven. One request, one event, one row in the database with many high cardinality fields. But infrastructure data doesn't quite fit this model. Infrastructure is ambient. There's a finite amount of network bandwidth available, and at any given point in time, we're using a certain amount of it, and it's useful to know how much we're using. There's always an answer to this question. At minute 1, we might be using lots of a resource, and at minute 2, we might be using none of it. Any number, including 0, is relevant, and instead, we're tracking events at a constant capture interval, here configured to be 1 minute. At Honeycomb, we talk a lot about cardinality, data that varies considerably in a particular field. For example, in our traces dataset, we're capturing an http.target field, which is basically different for every request, about as high cardinality a field as can be found. That's absolutely fine, and Honeycomb will handle this great, because in an event-based dataset in our columnar data store, high cardinality is very cheap. Metrics, on the other hand, are a bit different in this regard. You'll notice that we're capturing data from multiple hosts and multiple states. For every new host we add to this list, we're capturing one more data point at that time. And for every new TCP state we track, we're capturing yet another data point at that time. 12 states and 2 hosts means that we're capturing 24 network connections data points every minute, or 240 data points over this 10-minute span. Honeycomb can handle event volume like this just fine, but it's worth noting that cardinality works differently when you're capturing ambient metrics data from the way you might be used to in a tracing dataset. So I wanted to talk you through how I instrumented my system to send this data. There are actually 2 categories of metrics I'm collecting. There's metrics about the server runtime itself. How much of the heap are we using? When are we garbage collecting? How many Go routines are we using? How long has it been since the server started up? And there's metrics about the system. How much CPU is used versus available? How much memory is used versus available? What does network or disk throughput look like? Honeycomb accepts metrics through the new OpenTelemetry Metrics standard, an open standard that's supported by the Cloud Native Computing Foundation. It's growing in adoption, and major industry players, including Amazon Web Services, are starting to build in native compatibility for the standard. OpenTelemetry Metrics is also tightly integrated with OpenTelemetry Traces, which we've been offering for the past little while. I've got a process running on my servers called OpenTelemetry Collector. This process will collect metrics from the stream that it's running on, and it can stream them to external services like Honeycomb. It will also listen for metrics and traces coming from other processes on that host. and can forward those along too. On my HTTP server processes, I've installed OpenTelemetry SDK for Golang, which is responsible for capturing runtime metrics. I can also use this SDK to arbitrarily instrument and collect any other metrics I care about in my app with code. The SDK is forwarding its metrics along to OpenTelemetry Collector, which then aggregates them and passes them along to Honeycomb. So let's take a deeper look at OpenTelemetry Collector. It's configured with pipelines. Pipelines are made up of receivers, which accept or collect data from various sources, processors, which can modify the data they see in various ways, and exporters, which package data off and send it to various places. Some common metrics receivers include the host metrics receiver, which is what we were using to collect those CPU and memory graphs we saw earlier, or the OTLP receiver, which can receive OpenTelemetry metrics from other sources, like runtime metrics from an instrumented app. There's also receivers for common metrics protocols. For example, OpenTelemetry Collector can scrape Prometheus endpoints, and it can act as a receiver of StatsD or InfluxDB metrics. Common processors include the resource processor, which can add additional data to metrics, like, for example, stamping each metric with data about the host it came from, or the batching processor, which will hold data and release it in regular bursts, resulting in fewer requests downstream. There are many exporters, allowing you to send OpenTelemetry metrics on to a variety of endpoints. For the purposes of this demo, I'm sending metrics to Honeycomb, but hopefully you can see how a tool architected this way helps you to avoid vendor lock-in. All of this is configured in a YAML file provided to OpenTelemetry Collector. Here, you can see two pipelines configured, one for metrics and one for traces. The metrics pipeline is receiving host metrics, and I'll show you the sources that they're coming from these sources. And OTLP data is being received by this collector to port 4317. We then have a resource processor that's just adding a host.name and service.name field to all of the metrics in the traces, and a batch processor that's sending out metrics in 200 millisecond batches. Finally, you can see that we have a logging exporter, which can provide a bit of context as to what's going on with our pipelines when there are issues, and OTLP exporters set up to send metrics and traces along to Honeycomb. Additionally, in our application, we've imported the Golang OpenTelemetry SDK. We're configuring it to send metrics and traces to localhost port 4317. That's the same port we had configured in OpenTelemetry Collector. And here, we're configuring a new metrics controller, which is basically another metrics pipeline that lives inside of the server process. It has a capture interval of 1 minute and will receive runtime metrics from this process and send them out to OpenTelemetry Collector. Note, by the way, that all of this code is available on GitHub, and I'll make sure that there's a link in the chat for anyone who's interested in looking at this code in more detail. Also, pointers for the things that I'm showing you here can be found in our documentation. So once this is all set up, all this data can be found in the polyhedron metrics dataset. You can see that I've created a board called host metrics, where I've picked out some representative metrics queries. The queries from this board are what we were seeing earlier when we were looking at the metrics tab from a traces query. But you can also switch to different boards, or additionally choose from a list of suggested metrics in the new metrics section of dataset settings here. So there's something I should mention before I get too far ahead of myself. You'll notice when we make a query that there are some metrics that are showing as mostly straight up and to the right lines. For example, look at that system.cpu.time graph all the way on the left. What's going on with that? Does this mean that CPU utilization is steadily increasing over time? No. What we're seeing here is a special type of metric called a sum. Basically, every data point in this chart represents the total number of CPU cycles that have been spent on some activity since the server most recently started up. In order to get value out of this data, we need to be able to graph the rate of change of this number. That's basically the slope of the line we're looking at here. This is the next thing that our metrics product team is working on internally, and we're super excited to get it out to you. So there's one final thing I'd like to show you. If you'll remember at the beginning of this presentation, we saw this graph that showed the number of concurrent Lambda executions. These are also metrics, and they're coming to Honeycomb from AWS CloudWatch. If you, like us, are hosting your application on AWS, you'll be excited to learn that it's now possible to send metrics from CloudWatch directly to Honeycomb. Here's what the setup looks like in the AWS console. You can create a metric stream that's sending whatever metrics you want to send us. Here we have it configured to send everything, and point it to a Kinesis data fire hose with the Honeycomb API as its destination. This allows you to pull up all sorts of useful data in Honeycomb. For example, right now we're looking at a board with a collection of metrics showing you our various SQL databases hosted in RDS, with information about CPU and memory usage, but also showing query load and replica lag and other important database characteristics that might be useful to know about. So that about wraps up my demo. Before I end, I want to leave you with a couple of takeaways, things that we think are a unique strength of our metrics offering. First, we're using the same infrastructure to store and query metrics data as we're using to store and query the events that you're already sending us. That means that it's the same Honeycomb you know and love. There's not much additional surface area to learn, and metrics data will benefit from all the same features and capabilities that we're building for our events. Second, Honeycomb is embracing the OpenTelemetry Metrics protocol. And this is an open standard that's already tightly integrated into the cloud ecosystem. This means that you can avoid vendor lock-in, and it means that we're compatible with almost any metrics tooling you could add to your systems. And also, it'll be very pluggable with other tools you might be using externally. I'm really excited to share these beta features with you, and I'm excited to see how you use them. We've set up a new channel in our Pollinator Slack called Discuss Metrics. Please come chat with us there if you have questions, comments, or concerns. Thanks so much.
Max, that was amazing. Thank you for walking us through metrics. It's really exciting to see. We have a few questions.
I'm so excited about this new feature.
Me too. It's really cool. We have a few questions. So I know we initially built metrics with certain scenarios in mind, but the project evolved and we've seen a few customers use it. And so I'm curious if you want to talk about how the team's thinking has evolved during the course of the project.
Yeah, totally. So when we started out, I sort of thought of metrics as like your basic things like you're tracking about your infrastructure, like your CPU and your memory and that type of stuff. But we've sort of, throughout this project, we've developed a more generalized understanding of what metrics are for. And the way I like to think about it, I alluded to this in my talk as well, is metrics are, they're for ambient data. So when there's a thing that your system relies on, like for example, your host itself or some external component like a database or whatever else, it generally has state, and that state is consistent whether or not there are individual things happening. So with your traces, you're keeping track of individual requests that have responses, and there's a bunch of data that's sort of contained within the scope of that request. But the ambient data that sort of sits underneath that is always true. And metrics are kind of perfect for that type of data because they live regardless of whether or not anything is happening. Like if I want to know how many open connections there are, there's always going to be an answer to that question, even if the answer is 0. Whereas with an event, like asking the number of open connections doesn't actually tell you much about the event itself. It tells you about the underlying system that the event happened during. So I think that's the biggest thing, is that we sort of widened the scope of what metrics are for to sort of think about it in that way.
I love that framing of ambient data. I think it makes a lot of sense to me.
Yeah.
Cool. I want to ask you a question actually that came out of yesterday of Honeycomb. There was like this really interesting conversation in the closing discussion about dashboards and observability, and somebody framed it in, I know, it was very, very like just very cool. And somebody said in Slack, so if dashboards are bad, does everything start with a blank query? And I thought this was so interesting because it's something the team thought a lot about during when building metrics. I wanted to hear your thoughts on that. Does everything start with a blank query? How does metrics fit into that workflow?
Yeah. So one of the really cool things about the blank query is that it's kind of perfect for situations where you don't know what it is that you need to know, but you do know something. So like, for example, you have a question, you want to answer that question. With a dashboard, if you have a question, you can like scroll through the dashboard and hopefully there's an answer to it somewhere. With a query builder, your basic sky's the limit. You can ask it anything you want to ask. So that's really cool. On the other hand, sometimes it's also useful to have collections of data that you have looked at in the past. They're like, the thing about dashboards is that they're very static, they can't change. The reason that I ever use the boards feature, like I was using it in our at the very end of our demo just now, is because it's a great way to sort of just see like, hey, like there's stuff in this data set. What types of stuff are there? Like all of those things that are shown in that board were at one point a query that someone, like all the ones that were in that query or in that board were queries that I had made in the past. And I went through that process of discovery and I found some interesting things that I thought were kind of cool that I kind of just wanted to bookmark for later. So the board turns out to just be like a collection of bookmarks. Probably not the right place to go if you're trying to solve an acute problem, but a great place to go if you're like, oh, like what have other people looked at recently, or like what's interesting, or like I care about things in this category. I'm gonna look through that stuff. We also have our new metrics tab that shows up in the query builder. Our thought there is that for infrastructure metrics in particular, or for ambient data that has specific bearing on the system that you rely on, there are probably things that are always going to matter. So, for example, if you have pieces of infrastructure that you're using, like for example, you have like a message queue, and your app uses that message queue, and if the queue runs out of space, then like you have big problems. Sometimes it's useful to just be able to see like, oh, how's the message queue doing right now? Just pull that up. And that'll give you a really quick answer. Hopefully it's just a like, oh, there's nothing going on here. Like I can now not think about the message queue anymore. But it could also be, oh, there's a problem here, and that like short circuits the discovery phase. So that's one of the cool things about this new metrics tab is you can sort of just open that, quickly answer a question, close it again, or open it and be like, oh, I need to dig more into this.
Yeah, cool. So like boards as bookmarks is kind of what I heard, and a sort of memory tool, and then the metrics tab for investigating and quick reference, and then also diving in deeper. That's really rad.
Yeah, exactly.
I also wanted to ask you about OTel. The team chose to build ingest and support for OpenTelemetry Metrics, which is pretty cool. Can you tell us a little about that choice, how you think that shapes how folks use the feature?
Yeah, good question. So I'm stoked about OTel. I really appreciate Alalita's deep dive into the OTel project and sort of what's going on with it right now. It's also, Otel-Metrics is very, very new. It's still in early beta. And we are building our metric support specifically around OTel-Metrics, which means that we're kind of very reliant on that project continuing. And that's a little bit risky, but we think that it's an amazing bet to make because for a couple of things. I guess I talked about this in my talk as well. The OTel project is an open standard, so anyone can instrument their app with OTel and with OTel-Metrics, and they're not just stuck with Honeycomb. We hope that you stay with Honeycomb. We think that our tool is awesome, but it's actually, I think it's a really good selling point that you don't have to put Honeycomb specifically in your application. You can put OpenTelemetry in your application, and then hey, if you actually want to, connect to Prometheus server to your app, or if you want to, I don't know, send your data to multiple places at the same time. All of that stuff is super easy to do because of this open standard. So that's a huge one. And then also we're just really excited about where the project is going. And we think that there's a ton of amazing sort of extensibility, and there's a whole lot of really cool future places that we're kind of excited to build into as well. One example there that I'm personally quite excited about is exemplars. So individual metric streams can actually have links to traces in them. So if you're looking at a metrics graph and that metrics graph is actually related to your traces in some way, so like maybe there's something in there about your HTTP server and how it's doing. In the future, I'm envisioning a world where you can actually, just like you can click on a traces graph in the query builder right now and get sent over to a traces view where you can see a distributed trace of what your system is doing. You should be able to do that from metrics as well. And OTel's exemplar support will allow that at some point. So we're really excited about that. Among other things, OpenTelemetry is just really exciting. Oh, and then also OpenTelemetry collector is this amazing sort of middle piece that enables so much stuff. So because it's already existing, it's already widely deployed. And there are connectors in there on both the sort of ingest and the export side that know how to speak with a whole set of different protocols, InfluxDB, StatsD, CollectD, Prometheus, all of these things. So it's really easy to sort of mix and match where you want to pull data from and where you want to send data to. And it sort of makes everything feel really extensible and pluggable in a kind of cool way.
Yeah, I love this theme around open telemetry and extensibility and interoperability. I think it's really, really exciting. Well, Max, thank you so much for this deep dive. This was really wonderful.
Yeah, I'm super excited to I guess see what people do with metrics. I'm just over the moon about it.
Same. Awesome. Yeah.